For weeks, scientists weren't sure if what they were seeing was real. Strange shapes kept appearing deep inside the coma of 3I, Atlas, but there was a problem. The inner coma is one of the hardest regions to observe accurately, and imaging artifacts can easily fool even experienced researchers. Now that uncertainty is gone. New Hubble observations confirm those inner structures are real, physical features, not processing errors or visual noise. And that confirmation changes everything, because it means this interstellar comet isn't just active, it's organized in ways scientists did not expect. Why Hubble's confirmation matters. Hubble's confirmation carries weight because it removes the biggest source of doubt scientists had. Ground-based telescopes had already hinted that something unusual was happening close to the nucleus of 3I, Atlas, but those observations always came with an asterisk. Earth's atmosphere distorts light, and when you're looking at extremely fine detail near a bright, active comet, it's easy for false patterns to appear. Hubble changes that equation. Operating above Earth's atmosphere, it delivers cleaner, sharper data with far fewer variables. When the same inner coma structures appeared again in Hubble's images, in the same locations and with the same geometry, it became clear these weren't artifacts. They were real features embedded in the comet itself. That single confirmation pushes 3I why scientists first thought it might be an illusion. Before Hubble stepped in, skepticism was unavoidable. The inner coma is one of the most deceptive regions around any comet. It's bright, crowded, and constantly changing. When scientists enhance images to pull out faint details, those same techniques can accidentally create shapes that aren't really there. Lines, streaks, and apparent structures can emerge simply from noise, motion blur, or overprocessing. That's why the early detections raised eyebrows. The features looked too clean, too organized, and too persistent to fit what scientists normally expect so close to an active nucleus. Some researchers suspected the shapes were artifacts caused by image stacking or contrast enhancement. Others thought rapid changes in brightness might be tricking the software into outlining patterns that didn't physically exist. This caution wasn't a flaw in the process, it was essential. Extraordinary claims in astronomy demand independent confirmation, especially when they involve an interstellar object behaving in unfamiliar ways. Until a space-based telescope like Hubble reproduced the same structures under controlled conditions, doubt was the responsible position. Once Hubble showed the same features, in the same locations, with the same geometry, what these structures reveal about the nucleus. Once the illusion explanation was ruled out, the focus moved inward, straight to the nucleus itself. The most likely explanation for these inner coma structures is that they're being shaped by highly focused jets coming from specific regions on the surface. Instead of material escaping evenly in all directions, gas and dust appear to be channeled through narrow vents, creating organized flows that maintain their shape as they expand outward. That kind of behavior suggests the nucleus of 3I, Atlas, is not uniform. It likely has layered composition, fractures, or regions with very different physical properties sitting close together. Some areas may be rich in volatile material that activates quickly, while others remain sealed until heat reaches them. When those deeper layers finally open, they don't release material gently. They punch through existing structures, carving distinct pathways into the coma. This is especially significant for an interstellar object. Unlike comets formed in our own solar system, 3I, Atlas, comes from an entirely different environment. Its internal structure may have been shaped by conditions we don't fully understand yet. Seeing organized features so close to why this makes 3I, Atlas different from other comets. What sets 3I, Atlas apart is not just that it's active, but how that activity is organized. Most comets, especially when they're this close to peak activity, look chaotic near the nucleus. Jets overlap, dust flows smear together, and any structure that briefly appears usually dissolves almost immediately. Persistent inner coma features are rare even among well-studied solar system comets. With 3I, Atlas, those structures don't dissolve right away. They reappear across observations, keeping similar shapes and orientations. That persistence implies a level of internal control that scientists don't often see. It suggests the nucleus has stable vent regions that continue feeding the same pathways over time, rather than constantly shifting or collapsing. This is especially surprising because interstellar objects were expected to be more fragile and less organized. After traveling for millions or even billions of years through interstellar space, many scientists assumed such objects would behave erratically once exposed to a new star. Instead, 3I, Atlas, is showing signs of coherent internal behavior, something that challenges existing assumptions about how interstellar comets are built. And once that realization sinks in, attention naturally turns to what happens next. What scientists are watching next? Now that Hubble has confirmed these inner coma structures are real, scientists are watching for one critical thing: change over time. If these features remain stable, it would suggest the nucleus has settled into a sustained configuration, with long-lived vent systems shaping the coma in a consistent way. That alone would be remarkable for an interstellar object. But if the structures begin to shift, multiply, or disappear, it could signal something more dynamic happening beneath the surface. New vents could open, old ones could collapse, internal stresses could redistribute as deeper layers are exposed to heat. Any of those changes would immediately show up in the inner coma first, long before they affect the comet's overall appearance. Researchers are also watching how these structures interact with rotation. If the nucleus spins in a way that reinforces certain jets, why this update changes the story. Hubble's confirmation marks a turning point in how scientists understand 3I, Atlas. What once could be dismissed as imaging artifacts is now recognized as genuine internal structure, shaped by focused activity close to the nucleus. That means this interstellar comet isn't just releasing material at random. It's doing so in an organized, repeatable way. For an object formed around another star, that's a powerful insight. It suggests complexity, durability, and internal structure that survived a long journey through interstellar space. And because these features are visible right now, scientists have a rare chance to watch how such an object behaves in real time. Whether these inner coma structures persist, evolve, or trigger further changes, one thing is clear. 3I, Atlas